Hey everyone, I hope everyone is doing good. So today we'll try to solve a new problem which goes by the name remove colored pieces if both the neighbors are of same color, right? So we are given n pieces arranged in a line. So n there are n pieces, right, that are arranged in a line, and each piece is either colored A or it is B, right? So now we are given a string. So now there are two players, right? One is Alice and the other one is Bob, right? So they are saying that both of them can take alternate turns and then remove the piece, right? So now Alice is allowed to remove a piece, a type of color, right? And then Bob is allowed to remove B type of color, and they can only remove if it is like for A, Alice can only remove if the neighbors are also colored A. So for example, this is the case, right? So here she can remove this one because left is and right both are also same. So she can remove this. So eventually it will look like something like this. In the same way, Bob can remove if the color is of type B and the neighbors also have the same color. So Bob can remove B from here, it will become B. Now our aim here is, right, so and also they can't remove from the edge because here this is the edge, right, so it doesn't have a same color, it has no left neighbor, right? So the condition where it both the neighbors should have same color, that doesn't hold here, right? And now, so we need to remove this. First Alice will start, and we need to see like if Alice can win the game. Now there are a couple of cases, right? If Alice made a move and then Bob was not able to make any move, right, then Alice wins. But if in the starting Alice is also not able to move and make any move, right, then the other player, which is Bob, that wins. So this is the part that says that, right, if a player cannot make a move on their own turn, that player loses. So if in the starting only Alice can't do anything, then the Bob wins, right? So now that is the main gist of the problem, right? Now let's try to see how we can solve it, right? So if we take a look at the first problem statement that is given to us, test case, sorry. So now here it is, this is the test case, right? Now here we can see that Alice starts, she will remove this A and then it will become A, and then there is B, A, B, B. Can Bob make any turn? No, it can't, right? There is no B such that its left is also B and right is also B, right? So it can't do anything. So basically here Alice will win, right? So that's true. Now, so when we try to think of this problem, right, it sounds like something related to dynamic programming where we have this option, right? If we can pick this, then it will become this, or I can pick this, or I can pick this, right? That's the kind of intuition that comes into the picture. But if we try to see like what will happen, so for example, I'll take another test case. So the test case is we have A, and then one more A, and then we have B's, and then again we have A's, right? So our kind of intuition in other problems that we have seen is that if we can reduce this one, like we'll take, so for example, first let's say Alice took this turn, right? She'll make this as A, and then again it will take the turn. So next time, right? But once it is A, then it's turn of Bob. Now Bob, he will definitely, so this is the only option he has, right? He will definitely try to reduce this one. So it will become BB. Now, can Bob in any coming future do anything on this BB? On this BB? No. Because we need at least three. It should be left also, it should be right also. So what it concludes is, right, this thing is kind of independent. So if we are going in that track, that if this gets reduced, if this becomes 0 and then this A will match this A, then Alice may have more turns, right? Sometimes that's the intuition, that's the play that we are thinking. So if let's say I remove this part whole, then maybe our brain might be thinking that now we have more. So if we see, right, so here we had only 2 turns, here we have only 1 turn, but now here we may have more turns, right? So that's the kind of imagination. But this, even after Bob taking turns, right, that is not possible. So this kind of gives us the intuition that this is kind of independent. All the entries that Alice will take is independent. So that's the keyword here from what I understood, right? So independent is the kind of keyword that these A and these A are kind of independent to Bob's action. So now when it is independent, so then it is pretty much straightforward, right? So now let's say I have this A. Now for this, how many turns does Alice has? She'll pick this one, then she'll reduce one, so it will become AA. And then she'll pick again this one, right? So then it will become AA, no further choice, right? In the same way she can pick this also. If she picks, then this will go away, it will become AA, then again that same thing, right? So now this tells us that now in this, right, what is important is, right, they are saying that I can remove X color if left is also X, right is also X, right? So this is the intuition that we need to find the substrings of either A or B. So here in this example, why Alice can take max two turns, because there are substrings of A are only two. In this example, right, so there are three. This is one, this is two, and then this is three, right? These are three. So now in this way Alice can take three. So it's eventually the number of substrings of this part, A, right? So that's the intuition. In the same way for Bob it is this one. So those are the turns that they have. Now if the turns of A are greater than the substrings of A here, greater, strictly greater, because let's say even it is same, then Alice will run and then Bob will run, right? Let's say it is 1 and 1. Let's take example of this A and then B. So here it is same 1 1, right? Now I'll say that Alice runs, it becomes A, then Bob will run, right? Bob has a choice, then it will become B. Now Alice can't run, so she loses. So that's the basically whole intuition. Now this might be the brute force solution if you say, right, you just count the number of A, because even when you reduce it, right, it will not impact the B's choices, it will only impact the Alice choices, right? So that's, you may also call it as a brute force kind of solution, because you don't need to get into DP and all that stuff, right? If you go into DP thinking, then you may kind of make this more complex. So that's where this is kind of a easy, if we say that this is like it is leveled medium, but it is kind of a easy to medium level, right, based on the solution that we have. But see, let's try to code this one first, and then we can see whether this is the right approach or not, right? So now first of all, we'll take this as number of A's. These are the substrings of A, triple A's, right? And then we have same for BB. Initially we both are 0, right? And then we'll try to loop through our given colors, and we'll go only till the third last, so because we need to get the substring that is of length 2, right? Now here we'll see the substring colors dot substring of I comma I plus 3, right? So now this will give you the substring. So for example, if the test case is this and you are at I is equal to 0, so you are saying that give me substring from 0 to I plus 3, that is 3. Now substring works in this way, it will not take the third element, it will only take 3 minus 1, that will 2. So it will give you 0, 1, 2, these elements, right? So with that is, in our case in this example, it is triple A. Now if that sub, right, whatever sub we have got is equals to AAA, right, then our AAA increases, right? If it is equals to BBB, then our BBB will increase, right? Now in the end we just need to check whether of this Alice number of substrings or number of moves that Alice can make, is it greater? If it is greater, then you return true, otherwise you return false. Okay, the solution is accepted for these two. Now let's try to submit this one. Okay, sounds good. So this is basically the intuition behind it. I hope this video helps in any way. Keep coding. All the best. Have a nice day.